Hydroponics changes how plants access water and nutrients, but it doesn't change the fundamental process that keeps them alive: photosynthesis. Plants still need light, lots of it, and the quality, intensity, and duration of that light directly determine how fast they grow and how much they produce. Photosynthesis is a process by which plants convert light energy into chemical energy. Chlorophyll in leaves absorbs light, primarily in the blue and red wavelengths. That energy is used to split water molecules, releasing oxygen and producing sugars from carbon dioxide and water. Those sugars fuel growth, reproduction, and all metabolic processes. In outdoor soil-based farming, sunlight is free and abundant, at least during the growing season. In hydroponics, light can come from the sun, from artificial lights, or from a combination of both. Greenhouse hydroponic operations rely primarily on natural sunlight. Modern greenhouses are designed to maximize light transmission using high-clarity glass or polyethylene film. They're oriented to capture sunlight throughout the day and often include supplemental lighting for cloudy days or short winter daylight periods. Tomatoes, cucumbers, and peppers grown in commercial greenhouses receive a mix of natural and artificial light, with metal halide or high-pressure sodium lamps historically providing supplemental light. Increasingly, LED grow lights are taking over because they're more efficient and can be tuned to specific light spectra. Indoor hydroponic operations like vertical farms or warehouse grows rely entirely on artificial lighting. There's no sunlight. Every photon comes from a lamp. This gives complete control over the light spectrum, intensity, and photoperiod, but it also means electricity is a major operating cost. Lighting can account for 30 to 50% of total energy use in an indoor farm. Plants don't need all wavelengths of light equally. Photosynthesis is driven primarily by blue light, which is around 450 nanometers, and red light, which is around 660 nanometers. Green light, in the middle of the spectrum, is largely reflected, which is why plants look green. Early LED grow lights focus almost exclusively on red and blue, giving off a purple glow. Modern full-spectrum LEDs include green and other wavelengths to provide more balanced light that's easier on human eyes and supports broader plant physiological functions. Light intensity matters as much as spectrum. It's measured in micromoles per square meter per second, or ppfd, which stands for photosynthetic photon flux density. Leafy greens like lettuce need around 200 to 300 ppfd to grow well. Fruiting crops like tomatoes need 600 to 1,000 or more. Too little light, and growth slows, stems stretch, and yields drop. Too much light can cause photoinhibition, where the plant's photosynthetic machinery becomes damaged. Photoperiod, the length of the light period each day, also affects growth and development. Most leafy greens do well with 16 to 18 hours of light per day. Fruiting crops often need 12 to 14 hours, and some plants require specific day lengths to trigger flowering. Strawberries, for example, are day-neutral or short-day plants, depending on variety, meaning they flower based on day length. One advantage of hydroponics in controlled environments is that light is consistent. There are no cloudy days, no seasonal changes, no shading from trees or buildings. This allows year-round production with predictable growth rates. A head of lettuce in an indoor farm takes the same amount of time to mature in January as it does in July, because the light environment doesn't change. But this consistency comes at a cost. LEDs are efficient, but they still consume a lot of power, and they generate heat, which must be removed through ventilation or air conditioning, adding more energy cost. This is why indoor vertical farms are most economically viable for high-value, fast-growing crops like herbs and leafy greens. With a premium prices justify the energy input, light is also a tool for quality control. Red light promotes compact, sturdy growth. Blue light enhances flavor compounds and pigmentation in some crops. Far red light can speed flowering. By adjusting the light spectrum during different growth stages, growers can steer plant development toward desired outcomes. Whether the light comes from the sun or from LEDs, the principle is the same. Light energy is captured by chlorophyll, converted to chemical energy, and used to build plant tissue. Hydroponics provides the water and nutrients. Light provides the energy. Together, they create the conditions for growth that can exceed anything possible in traditional soil-based systems.